Okay, firstly, everyone, welcome to IMAS. I'm Richard Coleman. I'm Deputy Director of IMAS at the moment, but also in charge of one of the programs I'll talk about, the ARC-funded Special Research Initiative, which is called an Antarctic Gateway Partnership. So this is $24 million of money that's been highly prized and valued for helping promote both SOOS, but also to be able to drive some Antarctic research for the next few years. So some of you have already been here for the week, but welcome to IMAS. So this building was recently built from federal government money and state government initiatives. So I think while you're here, please enjoy the surrounds and part of the building. It's we're pleased to be in here. It's a nice building to work from in. So just to set the scene, really, I wanted to go through a little bit, just give you an overview of where IMAS is. Just to give you some brief stats, what government funding has come into what I call Antarctic and Southern Ocean research in the forward 5 years and where we hope to drive it after that. Talked specifically about the Antarctic Gateway project, how it's set up under its science programs or themes. And where SOOS fits into that, and just try and give you a link to why SOOS is important both for the Gateway but also for where this workshop's heading, Southern Ocean Antarctic work. So the context, and some of you are well aware of this, but within the Hobart Precinct, virtually within 100 metres down the road, we have CSIRO. So this is now an Oceans and Atmosphere flagship program. Something like 500 odd scientists and staff. Australian Antarctic Division, certainly their headquarters across the water here at Macquarie Wharf, which is the shipping area and where everyone heads south from, is about another 300. And IMAS itself now has grown, virtually doubled in about 3 years in terms of staff. So currently about 160 staff and about 135 graduate students. So within Hobart, we've got something of order of 60% of the Antarctic research capacity, and about 40% of the marine scientists are here. IMAS itself was established in 2010 at the university by collecting various groups around the campus and putting them under the one roof. So this was a push largely to create a large research driver for the university in terms of marine and Southern Ocean science. It complemented existing research with the Antarctic and Climate Ecosystem, CRC, but it brought together a lot of the university researchers and degree programs, if you like, the teaching and the research training arms together under the one building. So we moved into this building in January 2014, and that's been now a great initiative in terms of bringing everyone together with the other partners in the sort of marine and climate space. So currently the annual budget's about $45 million. The main part of that is that we've also generated something like about $75 million in research grants last year. We don't expect to repeat that every year, but we'll take it as it comes and be able to drive some of the agendas for the next couple of years. So as well, some of you have had a chance to walk around the building. Inside the building we have IMAS, the Integrated Marine Observing System, and on the upper floor, Tony Warby's here, is the CEO of the ACE CRC. So within the building we have pretty much a lot of integrated and complementary research programs working. And of importance for this meeting, Louise is in charge of the SOOS office, and the SOOS office is also contained within the building. So it makes it pretty easy to do work and catch up with people all in the same environment. So within UTAS, I guess it's largely been renowned now for temperate marine work, Southern Ocean and Antarctic work, primarily responsible for the education and research training, but it integrates with the other agencies in terms of providing the research training. I think now we're fortunate to have new national facilities, both with a new research vessel, RV Investigator, There's a look to get a new icebreaker as well to replace the Aurora. But complementary to all of those, we have a range of facilities now that provide great research efforts in terms of the observing systems. So with the IMAS office in particular, it helps provide a unique opportunity. So IMAS itself is split across 3 different areas. You're sitting in the Princess Wharf part of IMAS. Down in Taroona, a suburb in Hobart, there is the Fisheries and Aquaculture Group. And as part of the merger, we also, if you like, recollected an aquaculture school that was in Launceston. So they've now been brought back under the IMAS umbrella as of the middle of last year. So this is where IMAS has now got 3 footprints and brought together mainly all of the marine fisheries groups together within the university. So as part of the new infrastructure that we're enjoying is the IMAS building itself. There's currently work underway building an experimental aquaculture facility down at Taroona, which is a $7.5 million aquaculture facility, again jointly funded and integrated with industry, but also again with other groups within the state. IMAS, just in terms of how it's laid out, it's got 3 centres and split within, again, 3 cross-cutting themes. So Oceans and Cryosphere, and Nathan's here as the head of the Oceans and Cryosphere Centre. There's a Fisheries and Aquaculture, Chris Carter at Taroona is leading that, and Craig Johnson is in charge of the Ecology and Biodiversity Centre. And then the sort of cross-cutting themes across all of those centres are climate change, ocean earth systems, and ocean and Antarctic governance. So, you know, IMAS has the name studies at the end rather than science. It's a multidisciplinary, interdisciplinary group. So it largely is pretty unique in being able to do from physics to biology to fisheries to social policy areas. So it spreads pretty wide across the range of law and policy to mass physics and chemistry. Now, as I was saying before, integrated within the environment, we have really significant collaborations with CSIRO and IAD. There's 2 unique PhD programs within IMAS, one called Quantitative Marine Science, which is a joint PhD program with CSIRO, modelled on the MIT. So we give compulsory coursework to PhD students, which is a bit unique in Australia. It's not a normal. And we started 2 years ago a quantitative Antarctic science PhD program with AAD. So these programs have typically got, for QMS, at least 30 to 40 students per year within the program. In terms of where we're heading with government investment, so a lot of these were within the current government's pre-election commitments. The first one here that's listed, Tony Warby is here, now CEO of the new renewed Antarctic Climate Ecosystem CRC. So this is the CRC program. This CRC in some form has been running for 20 plus years. So it's really been a driving force of producing a lot of the science within the international sphere for marine and southern ocean. So it's a collaborative CRC with a number of agencies, including the sort of the main three within Hobart, the university, CSIRO and AAD, but it includes a number of something like 13 international partners, and now also includes the Bureau of Meteorology. So it's funded for about $5 million a year for 5 years across 2014, started in July 2014 out to 2019. So the other new part that I'll talk about is the Australian Research Council. So this is the main funding agency for universities within Australia. Special Research Initiative, Antarctic Gateway Project. So this is specifically a grant to the University of Tasmania to work with CSIRO and AAD to drive Southern Ocean research. So under that umbrella, we have funding for about 14 postdocs. Most of those are now pretty much on board, or will arrive by about August this year. Got 24 PhD scholarships, and then, as I'll talk about, quite a large amount of funding to generate logistic support for getting people into the Southern Ocean to do field work, or onto the cryosphere or the ice shelves and ice sheets to do field programs. Some of you may have been reading the local news. There's been a commitment to upgrade the Hobart runway, whether it's got air bridges or whether you have to get the Hobart environment and walk off the plane and walk across the tarmac and get checked out by the sniffer dogs as you walk in. I think they're trying to change a little bit of the Hobart friendliness and change the structure, but the idea is to extend the runway so that we can bring in larger aircraft, international flights, specifically to provide Hobart as an Antarctic gateway. And to complement that, there's been money put in to upgrade the port facilities and provide or maintain the Hobart Antarctic Airlink. So I talked also about the investigator. So this is a national facility where everyone bids for time on research vessel. The first season was the 2014-15 season, and that was from the trials that have been done, a highly successful and really exciting voyage. Currently it's funded for 180 days of ship time. It can do 300 days, and so there's some discussion going on how to be able to fund the additional sea time days. The Antarctic Division have been given the okay to look for a replacement for Aurora. A new ship may be online by 2020, but again, it means finding money from government to be able to put into that. So this will be, multi-million-dollar program where the multis are quite a large number, and it's a big expense in terms of running and operating. In terms of the Antarctic Gateway project, so this was, as I said, $24 million of ARC money. It started really in terms of what I'd call starting in November last year when the first check arrived. We had by January this year about $12 million to use in terms of starting the program. So the idea really is linked to 4 different themes, but in terms of a high-level strategy, it's really looking at the influence in the polar environment of changing climate, both from looking at ice shelves and ice sheets, understanding the effect of sea ice and ice on the ocean environment, both from the ecology and chemistry point of view, and an attempt for Australia with the Australian Maritime College, which is part of the university in Launceston, to build an underwater autonomous vehicle to be able to probe under ice, so either under sea ice or under ice shelves, and to develop a sea ice forecasting capability. So some of the speakers last night gave their favourite slide. This is one of mine, but it's the Amory Ice Shelf. So just to give you some idea of the size, at the moment it's good for looking at. We don't have the capability of getting back there too often. We've got a few instruments that have been sitting there keeping the ice shelf in company, but we haven't been able to get the instruments off. So this ice shelf itself is one of the biggest in East Antarctica, which is the area for Australia, about 500 kilometres long, about 300 kilometres wide. So it's a significant ice shelf. A lot of the work that we've been doing is characterising it. Australia's been sending various expeditioners there for over 50 years, but in recent years we've had limited access. So the loose tooth was one of the projects that I was working on, which is that sort of big fracture at the middle. We figured it would carve in the next 5 to 10 years, but at the moment we can look at it in visible imagery but not get back there to actually measure it. So in terms of the gateway, Anna showed quite a few of these slides yesterday. It's pretty much the same. We're interested in understanding ice shelf ocean processes and their interaction. So it's really, and Keith also talked about it with the Necklace program, understanding from the ocean side what's happening underneath the cavities with basal melt and accretion, starting from the top, what's happening to the ice shelf with accumulation, change in velocities, the ice shelves themselves, and then understanding what the fluxes are. Again, similar to Keith, it's understanding what the contribution to sea level change is over time. Is what's driving the change in the ice shelves themselves. So theme 1 is really looking at trying to understand the influence of basal melting on the ice shelves. We'll probably be looking at the Amory and the Totten, which has been studied from the past season, but maybe a few of the other glaciers in between, and trying to quantify the input-output from the ice shelves themselves to figure out what the contribution to sea level change is. Theme 2 is looking at open water and under ice food webs. Andrew and Jess gave a nice talk yesterday that looked at some of this. The Gateway is complementary to that in a way, looking at mixing up between experimental work in the lab, looking at changes in conditions of the ecology with changing temperatures and acidity within experimental labs, but then also using biofloats and field experiments to understand what's happening in the Southern Ocean. So Phil Boyd's leading this particular theme, and we've got about 3 postdocs in this region, in this theme, looking at various parts of the biofloats and biogeochemical sensors to experimental work with microbial lab work, and then looking at mesopelagic history. Theme 3, this is led by Matt King. It's a solid earth cryosphere interaction project, split in across 3 areas, looking at geothermal heat flux of what's happening with the ice sheets themselves. So understanding from a basal melt or from a geology point of view, how the ice sheets have evolved over the past 20,000 years and what some of the driving forces are underneath the ice shelves themselves and the ice sheets. And then 2 modelling groups looking at the paleoclimate of the ice sheets themselves. Again, focusing really on the last 20,000 years. It complements the work that the CRC are doing with the Ice Core group. And then the integrated part is having an ice sheet, ice shelf modeler looking at the integration between ice sheets and ice shelves and the boundary conditions that are forcing them. So one of the particular works that Matt King is looking at, hopefully in the next few field programs, is looking at this context of glacial isostatic adjustment and how that influences part of the ice sheet history. Theme 4 is looking at trying to build this next generation polar capable AUV ROV. So this is led by Neil Bowes at the AMC, and so this is a Gavia that was used last year. The group have got a Gavia machine. So this is a few researchers that joined, went to Scott Base and drilled holes in the ice and used their system for being able to take measurements underneath sea ice. So the idea is to be able to have a vehicle. We're still in the tendering process, but looking at capabilities of probably a longer range vehicle, maybe up to 500 to 1,000 kilometres, maybe getting to depths of 3,000 to 5,000 metres. So depending on how you set up the design, you get to have different access. So, at the back of the Amory, it's 2.5 kilometres thick, so you need capabilities getting in underneath. A bit dangerous to send it 500 kilometres in and back when you've only got about 1,000 kilometre range, so I don't think we'll be doing that the first time. I have asked Neil how long a bungee cord he needs on his instrument so that we get it back. There'll probably be quite a lot of testing in coastal areas to start with before we risk sending off about $5 million worth of equipment and maybe not see it again. Maybe have to get some lessons from Keith and the auto sub people. There's quite a few of these systems in the world, but it's one of these highly technical areas, but provides, if it does work, a wonderful capability of getting in under ice shelves to see and understand the physics and chemistry that we haven't been currently able to do. And one of the other parts of the theme really is to look at the polar environment from a sea ice forecasting capability. So Tony Warby's helping lead part of this work, which is to make sure that we don't get ships stuck in the ice when we send them down, to be able to have a capability of certainly operating from the East Antarctic area in giving ships forecasts for the current season and being able to manoeuvre in areas where it's worked before, and to design field programs. So this is just to give you a few highlights and questions, given Steve's in the audience and Esme are here, so they can probably give you a better rundown on last season's work. The Antarctic Gateway Partnership provided funding that enabled a lot of these two field programs to happen this year. So there was a field program on the Totten, which was, from Steve's comments, the best ever in terms of the luck. So in Antarctic field work, it either goes really well or complete overload and you get nothing, or somewhere in between. So this season was one of those where everything seemed to work the right way. The leads open up at the right time. You could get into the areas that you wanted to get into. There were 6 ocean moorings that have been sitting under the ice for the last 2 years, taking measurements, and I think you got them all back, Steve. So tried to get them back previous years. This was the last season to get it back, and everything seemed to work. So there's use of University of Washington gliders. We had autonomous floats, and we could get close enough to the Totten to get the first ever measurements that were within about 50 kilometres of the ice of the Totten Glacier. So it was one of those great field programs where everything worked. You've got a great data set to now look at what goes into the future. And similar to the Copery work, there was also hydrochemistry on board that you can now start looking at glacial melt from the chemical traces that come out. The other part that is led by AAD, but initiated from an original ARC LEAF grant, which is a large equipment grant. There's a free ocean carbon enrichment experiment that's being done at Casey. So there's 4 underwater, if you like, containers that they're using for running essentially a carbon experiment, changing the pH or reducing the pH by about 0.4, which pH unit, so which is about maybe at the top end of what's expected by 2100 in terms of changing climate. So there's 2 containers that are control experiments, and there's 2 containers that are used in terms of changing the pH, and then looking at the biological changes in all of the microorganisms, the soil, and the community aggregations over the next few years to see what happens. So these things are in place in about 30 metres of water near the Casey station. And I think they were in from about November to March over the summer season. So the aim for the future, or one of them, and where it brings it back to SOOS and trying to integrate a lot of the work. So the main push from a number of the themes within the Gateway is to get to an ice shelf and be able to monitor it, both with oceanographic moorings and data, being able to get an AUV in underneath the ice shelf, and to be able to, as similarly been done for the AIMRI, to have boreholes and in situ instruments within the ice shelf itself, to be able to understand it, as well as then sensors from remote sensing on top. We've acquired from Keith from BAS a number of these AP-RES systems to measure melt. So on the AIMRI we've got 2 systems currently, but we're trying to raid Keith's lot to get another 15 to deploy on another ice shelf. So probably the easiest logistically would be the Sawsdorf, but there's also plans to get to the Totten and probably back to the Amery. But certainly the next few seasons, the Sawsdorf will be the main focus, which is near the Davis station, in terms of trying to do both an integrated ice shelf ocean experiment. So in terms of where the Gateway is driving, a lot of it is complementary to ACE's work, but largely to look at sea level change from understanding the ice sheet and sea level rise, providing a capability for applying some of that into the policy space, but learning a lot from the on ice and under ice measurements that we've made during this program from the development of the AUV, and then what the integrated modelling part will be. A lot of this work hopefully will lead to driving some of the IPCC reports for the next IPC 6. And in terms of driving capability within Tasmania, if you like, and within the Australian community, to provide a capability of observing under ice with the AUVs, ROVs, and the development of the sea ice forecasting, which might end up being inside the Australian Bureau of Meteorology. So getting back to SOOS, so the early part of the workshop and for the next few days we'll be looking at where SOOS is going to drive it for the next 5-year program. The Gateway is currently providing the SOOS office help in terms of operating budgets, a data officer, and help with Louise in terms of the SOOS manager. So we see this as a really important part of capability to go forward. So within the Gateway project, we can support it for the next 3 years, and that gives us time to be able to make it if you like, a continuing program within the international community. So within the Gateway itself, it will provide data sets across the ocean chemistry, biology space, and also from the glaciology area. In terms of the synergy, certainly for IMAS and within the Hobart community, it provides a critical mass of being able to link to other international programs. It certainly gives profile to the Hobart community in terms of where it's structured. Everyone's here, being able to interact with the researchers here. So I think it's this broadening of international research experience that provides a great focal point for SOOS. And that's the end of the talk in terms of happy to take questions or open it up.
Time for one or two questions. It's
right.
great.
Up for one. Oh, okay. I was all really exciting outlook, actually, really impressive. I'm just wondering what the possibility is of going from a sort of like a 3-year type program or 5-year type program to continual sort of sustained monitoring in some small areas, maybe of rather reduced data sets. Do we have any plans for that?
Yeah, that's where we want to try and build it, Keith, in terms of being able to have areas of ice shelves that we continually monitor, as well as ongoing enduring programs. So between the CRC and the Gateway, we have, if you like, a cliff of funding. There's no forward commitment by a government or otherwise for forward funding. So that's the aim of a few of us collectively to generate what happens after that. So I think we're reasonably hopeful. You know, the CRC was funded for 20 plus years in its current form, and it's really how the government views that. There's a 20-year Antarctic plan that Tony Press has submitted to government. The government are currently making their response back to that report, and some of those recommendations were pushing back to provide continuous logistics to be able to do the Antarctic science. So I think as a community, we're reasonably hopeful that we'll be able to continue, but there's always government decisions that change it. So from our point of view, we keep pushing in grants and writing proposals. But as you know, that's a pretty hard cycle to keep going continuously.